All right, this is Hangops. We are live for February 6th, 2015. It's hard to believe we're already a month into the new year. I've got some really cool guests and a great topic today. We're going to be talking about auto-scaling groups, which is a really sort of interesting and maybe not well-known enough set of features in AWS, part of what makes the cloud magical. So we're going to kind of get into that today with a couple folks from Drama Fever. We'll start with a couple introductions. Bridget, you want to tell us who you are?
Sure, absolutely. So I'm Bridget Kromhout, and thank you, Brandon and Chris, for having me on again. And I'm an operations engineer for Drama Fever, and I've been there for about 6 months now, and the stuff we're doing is pretty cool, so I'm excited to talk about it.
Awesome. And Tim, I think this is your first time on. Welcome.
Yep. Thanks for having me. My name's Tim Gross. I'm the director of DevOps at Drama Fever. I've been with the company for about 3 years. They brought me on right as we were kind of getting out of a couple of Apache boxes to the kind of much larger scale that we're operating at now. It's been a lot of fun being with them for that time.
Cool. And if you both could a little, like, what is Drama Fever, and kind of what sort of scale are you at? Like, what kind of what's your like usage pattern?
Sure.
Sort of set the tone of your infrastructure, and then your clients and users and stuff a little bit.
Sure. So we're effectively a Netflix for foreign television. So we license content from mostly East Asia, a little bit of South America, a little bit of Europe. And we stream it to a global audience, predominantly right now within North and South America. We also run one additional property today for AMC, one of our early investors. We have a partnership with them where we run the Sundance documentary site, .club. And we also, in another couple months, are going to be releasing another product with them called Shutter, which is a horror product. So it's online streaming media, very similar to Netflix in terms of the kind of usage patterns that we see. We're all deployed on AWS, so that we use Akamai for our content delivery for our streaming media. In terms of kind of like the load that we're talking, we're on our peak loads will be in the tens of thousands of requests a second to the main site. That doesn't count any of the streaming media to the CDN. So we're kind of operating on that scale. One of the things that was really kind of relevant to the topic that the auto scaling topic is that that load, because today we're really heavily focused within the North American and South American kind of vertical band of the globe, that load swings by about 10x throughout the course of the week. So the Monday morning at 7 a.m. Eastern load versus the Thursday, Friday night load is 10 to 20 times now over that, in terms of requests a second. So
It's kind of that sine wave that you expect to see if you don't have the huge amounts of viewers everywhere around the globe.
Right.
Which is sort of tied to content licensing, regions, that sort of thing.
Yeah. The audience is, although kind of with the content that we have, which is a lot of foreign television, you'd think that our audience was a lot of expats and immigrants, but it turns out that we have a really huge audience, predominantly urban audience, majority female audience, just kind of the nature of some of the content we have, which is a lot of like romantic comedies and melodramas from, say, South Korea. So really. There's kind of a really large fan community within North America on that content. So that's the kind of stuff that we're streaming.
A bunch of whom showed up for the awards show we had last night. It was a fans vote, and Toyota sponsored, and we had K-pop stars and South Korean drama stars actually in here. Well, Tim is in Philly right now. Today I'm in New York, and last night in New York City we had a whole event full of fans that were there to see all of these stars. So it was fun seeing how passionate our fans were about it. Because usually, I mean, we see that a little bit at a remove, and seeing it in person was certainly something.
Sure, sure. Passion doesn't come out very well in Nginx logs, oddly enough. So.
Okay, that's really interesting. So then, in terms of sort of your backend infrastructure, I would imagine it's a lot of like web services, APIs, sort of.
Yeah. So when I started about 3 years ago, they were running a Django application. Was the entire application was a Django application, which is a Python web framework for people who aren't familiar with that, with Apache sitting in front of it, and then just behind an Elastic Load Balancer, and that was the entirety of the application, with a MySQL backend. Today, that has kind of grown a lot of tendrils, and we've kind of gone into a more microservices infrastructure. So, kind of at the core of it is still that same Django application, but we have I think 8 or 9 different services today that serve other projects, like video analytics ingest, image process, on-the-fly image processing to do, image compression and resizing, cropping, notifications, asynchronous workers.
Bookmarking, pretty important to users who are watching something on one device and they want to pick up where they left off.
Yeah, so there's a whole pile of those. Today, those over the last couple of years, those have all gradually become written in Go. So that's kind of the other fun thing that we have going on, is that a lot of our development these days is almost all new development, new projects are being done in Go rather than in Python. So that's been really exciting.
And I mean, it's sort of orthogonal to this particular discussion, but maybe not really, actually, because it definitely plays into our auto-scaling stuff, is also the fact that we are pretty heavily invested in Docker. So that definitely, the inducement of, hey, come to Drama Fever and you can work on Docker and Go all the time, is actually a pretty good recruiting tool. I know it worked on me.
Well, and it's interesting because, like, we're going to leave my opinions of Docker out of this, but it does provide an interesting thing to think about. If you're deploying Go binaries in Docker, like, there's a lot of positive to be said about that, even if the only thing you can say is that it's been written fairly recently. So a lot of the maturity that comes with, or the maturity that's needed when you run with Docker, you can have, because you're not like dealing with a legacy code base.
Sure. I think like getting getting, say, a heavyweight Python application to like Django, let's say, with its there's probably 60 or 70 different dependency library dependencies that has to run. Obviously, is a lot more involved to get running. Plus its relationship with static assets and static asset pipeline processing. Kind of all those steps, are definitely way harder than a statically linked binary. We just recently, I don't think it's not in production yet, but we've recently gone from a thin container for one of our Go services to an extremely thin container where it's from the scratch container, and so it's just the empty 0-byte scratch container with the statically linked binary and the SSL cert file, and that's it. So it's a 10 meg container, which is that's going to be really great to deploy, because obviously you can pull those really fast off your registry, and so boot times are fast and just less stuff to ship around.
So how does that
actually? Yeah, I was going to say that ties directly back into what it's like to auto-scale this stuff up, which I suspect is where Brandon was going. But that's kind of a good segue into exactly what we actually do in terms of, or maybe Chris was going to go there, I'm not sure, but you know what I'm saying.
Mm-hmm. That was going to be my next question was, okay, so cool, you've got Docker, but like, yeah, there's this weird, I have this moment of, okay, so you've got Docker on top of something that auto-scales, so do you have like an auto-scale group inside your auto-scale group so you can auto-scale all the things? Like, how does that all work?
It's a turducken made entirely of Docker and Bash.
So I guess the way I would explain, so the way that the kind of, and I don't want to use the word traditionally use autoscaling because that sounds like a very strange thing to say, but kind of the model under which autoscaling was designed is this idea of like immutable infrastructure, right? Which I think is a really hugely powerful model, and I think is, the more that we can do that sort of thing, the better. But there's this idea that you say, okay, well, there's a separation between what's going on the host and what's going on these Docker guests. So for us, what we're doing is we're deploying identical hosts everywhere, and we bake an AMI from that. We're using Packer to bake those AMIs now. That AMI gets baked and added to the autoscale, and then added to all the autoscaling groups, and then the user data is what bootstraps the initial chef run and the I'm sorry, and pull and
which picks a role that the chef run will run from.
Right, and that role is what says run these containers on that instance. So really, our hosts are, regardless of what services what autoscaling group they're part of, the hosts are all identical, and then they're all running a different set of containers that's determined by the user data that's that we give it at start time.
And that gives us a lot more flexibility than like at a previous job where we were using autoscaling pretty extensively, but we needed to bake different AMIs for each of our pieces of the infrastructure. The API serving stuff versus, I don't know, the asynchronous worker stuff or whatever. It's very nice to have one base AMI that we can use everywhere.
So you're autoscaling the ships, and then what containers go, or what shipping containers, using that analogy, end up on those ships, end up there based on user data. So do those just auto register them with whatever you're using to load balance across them? Because I think one of the things that is killer about a lot of these discussions is there's a lot of kind of implicit aspects that a lot of us understand because we've been at this for a while that aren't always obvious. Like, I would guess that most of us that are on the call, if we say service discovery, we're like, oh yeah, we get it. Like, that totally makes sense and whatnot. But I would guess that there's also a lot of people that watch this that are like, service discovery, what's that?
So our model for that is actually is pretty simplistic. We try not to build a lot of stuff on top of it, but so what we do is although we're using that same host everywhere, we have different auto-scaling groups for each of the roles. So there's a bookmarks role, a celery workers role, a www servers role, and those are each their own auto-scaling group. And that gives us two things. One, it gives us an easy way to do service discovery, which I'll get to in a sec, but it also lets us scale them independently depending on the load to those services. So and just kind of goes back to the question we were talking about just before we started, where we have two sets of servers that have a really large swing in load over the course of the day, whereas there are other ones that are really, we have multiples of those because of redundancy, not because of load. So they won't typically scale, but
they will sometimes, right? I mean, if it's Saturday night, they probably will, but most of the time they won't. Right.
So then, in terms of like that question of service discovery, really what happens is when and that's part of the autoscaling API, so that when an instance comes up, it registers itself with a load balancer, and we're with the elastic load balancers from Amazon. So we're using that. If you're using that service, you get that kind of for free, so to speak. Although they've recently added, and this is, if you're not using the EOB, say you need a more elaborate load balancing thing like HA proxy, they've recently added lifecycle hooks so that you can say, oh, and when the instance starts, then execute this, which could be arbitrary code that you've written that says, okay, now register me with my HA proxy load balancer or with my console service discovery or whatever it happens to be that you're using in your environment.
And I think something else to keep in mind too is having your autoscaling group automatically attach instances that launch in that autoscaling group to a specific load balancer or load balancers, plural, is actually optional. I mean, you don't have to set that in the autoscaling group config. And at my old gig, we didn't, because we instead had like deployment scripts that would, various on-boot scripts that would run that would basically do the stuff that now Amazon is actually building in. But one thing that's kind of that we just noticed when we were building out a new part of the infrastructure that's sort of annoying is if you have an autoscaling group that exists, you can add multiple ELBs to be targets for instances launching in that autoscaling group, but only at autoscaling group creation time. You may not modify the ELBs that an autoscaling group uses, nor may you add to them after creation time. For whatever reason, Amazon has not exposed that. And that's kind of one of those things, like when you start digging into the very specifics of these tools, you find a lot of things like that, and you're like, oh, okay, that's good to know. It would have been maybe good to know before, but we know now.
So, like, when we talk about autoscaling, so there's two aspects of this, right? Like, my favorite one being, is it how auto is auto? But also kind of, so it would be probably useful if you've never played with autoscaling in AWS to kind of talk through how the auto works and what happens as part of that, like the way the definitions work and yada, yada, yada.
Sure. You want to take that one, Bridget? I've been talking a lot.
Sure. I mean, I can address a little bit of it. I think you're going to probably have to talk about the strategy behind some of our CloudWatch alarms because I didn't design them.
Okay.
But you can trigger auto scaling based on CloudWatch alarms, and so in Amazon, you can do custom CloudWatch alarms. We haven't actually done anything quite that fancy yet. I think on almost everyone I've looked at least, and this Tim can correct me if this is wrong, but I think we're just scaling based on CPU load of the host instance. So if the CPU is starting to spike, that's a reasonably decent correlation for us with these services are getting too busy. And for like some of the upstream services, and I think we didn't really talk about it, but we're basically just upstreaming, proxy passing or whatever, a whole bunch of stuff via Nginx to the microservice that we want to send it to. So if an upstream service starts, laboring under load, like we'll just have the CloudWatch alarm automatically trigger, hey, launch, spin up more instances. And then there's a lot of stuff you can set with like a grace period and kind of a cooldown period so that you don't, once you've spun up more instances, hey, give yourself 5 minutes or whatever before you see whether or not you need even more. And then in the opposite direction too, in terms of scaling down. I don't know if that kind of covers what you were asking or...
No, it does. Can you use custom things to scale that up? Like,
Yeah, we aren't yet, but Amazon did add support. When was that, Tim? Like, I don't know, 6 months or so, maybe?
Yeah.
Ago for custom CloudWatch metrics. So you can make a CloudWatch metric that's something more like, I don't know, the number of hits coming in right now or whatever. Like something more related to your business logic. We probably will. We just haven't done it yet.
I think so. One example for the web for things that are servers, meaning things that are serving web requests to users or to a service that is serving a user directly. We're using, as Bridget said, we're using the CPU for all that stuff. But one of the areas that we have some of the other tasks or some other alarms in play is so we monitor we have CloudWatch alarms on our SQS queue. So that's basically our asynchronous task queue. So as we watch that if it gets to high watermarks, then we scale up the asynchronous workers to take up that load. So usually, we have, a modest pool of those that can process them at a speed that we're happy with, and then we kind of just keep an eye on it. And when, if there's a backlog of new events or something like that, or we just, spin up some instances, burn down the queue, and then it slowly burns back. They slowly scales back down, on demand. So typically, we end up with
down to a minimum. I mean, we do set a floor.
Right. You set a minimum and a maximum when you do these. So you can say, if the average, and just to kind of like a specific example, if the CPU on these is higher than 75, if the mean CPU is higher than 75% utilized for 10 minutes, scale up 2 instances. Like that's the kind of way that you write those rules.
And we also, from Dave Mango, I hope I'm pronouncing your name correctly, Dave, on IRC, we have a question about the deployment of new containers, as in, like, is it done, quote-unquote, hot, or do we have a new AMI brought up and then the latest container installed by Chef? And the answer is neither really. Like we actually this kind of ties into a whole thing we're doing with our Docker stuff. With that we sort of alluded to earlier, but didn't really go into clarity about, or like more detail about. But Tim, do you want to talk a little bit about the motivation behind our private registry?
Right. So there's a couple of pieces here. So let me address the private registry first. So one of the things that we ran into when we first started with Docker is that we said, okay, they give you this Docker registry application that you can run, and it's just a Python application. It's unicorn. You put Nginx in front of it, and it sounds like you're happy with that. You can say, okay, here's a place I can put our containers that are not going to, not be publicly readable, which sounds good. But in, say, an autoscaling environment where you might say, oh, this queue has backed up, so let's spin up 20 new workers all at once, burn the queues down because they've backed up because something was going wrong. Now, all 20 of those workers are going to hit your Docker registry simultaneously, and it dies when you do that. So it gets really unhappy. So what we've done instead is we have the Docker registry application running on each of the hosts, and then it's using as its backing store Amazon's S3 storage. So essentially, the registry application is running on the host and acting as a proxy to S3, so that when the instance comes up, it says, okay, pull from the local registry to find the containers that I should be using, but those are all actually stored on S3. So you fan that, so that load is all on S3 and not on a box or multiple boxes that we have to run the registry. So it adds a little more complexity to the host in that respect, but it makes those pulls of the containers a lot more reliable, particularly for some of our larger applications, which the containers can get to be like a gig, that size.
Though with some of the Go stuff now, that's actually going to be, I think that'll make the auto scaling for those instances way faster, just because it'll be able to pull that 10 meg container down super fast.
Right, yeah.
So we don't have Chef giving us a new container. And we're also not baking the new container into the AMI because the AMIs are actually, don't have any containers at all on them. But it's like we auto scale up and then we say, go get the thing that's currently tagged for prod for dub or whatever.
That makes complete sense. And I hadn't thought about it, but that idea of running the container service on the local host, kind of like you do with from a service discovery perspective, a lot of times it makes sense to drop load balancers on the back end of your box to not have a central load balancer be a failing point.
Right.
Yeah, I think a lot of this was just around that you and Paul came up with was to get around the single point of failure.
Right.
We don't like single points of failure.
So we've talked a lot about auto scaling group and stuff, but I don't know that we've defined the key terms and concepts of it sort of as a service. So maybe we can take a second to do that.
Sure. So, all right, yeah, let's kind of go down to the basics.
Maybe start with the auto scaling groups and launch configurations in AWS's implementation are related, but not the exact same thing.
Right.
Which I think is one place where I know when we had a new person, Pete, start recently, and he's a brilliant guy, done a ton of stuff before, and had not actually used AWS extensively before. And he had some of the same questions I had a few years ago, which were like, wait, we're setting up a launch config or an auto-scaling group, and what's the relationship between them? So maybe we should start there.
Yeah. I'm gonna like just briefly start one level below that, which is that kind of, so the unit of the build is the AMI, right? So the Amazon Machine Image. So when you've created your host, you take a snapshot of that, and that's a disk image that represents something that you can say, okay, take this disk image and give me, and this is not specifically related to autoscaling, but in the Amazon environment, if you're not very familiar with it, you can say, take that disk image and bring it up on this hardware with this configuration. So that's kind of like the way that a single instance comes up. So a launch configuration is a way of describing via the API just that process. So you say, okay, a launch configuration is a configuration that says, this disk image, this AMI, on this hardware with this networking environment, with this SSH key, with this security.
This security group.
Right. So like what firewall environment it's in. And there's a whole ton of those steps, and one of them is the user data as well. And so user data is it's a free-form text or file field that is part of the API, and that is something that it will run as part of its bootstrapping process. So that's kind of where we hook in things like the Chef client runs and things like that. So that launch config is is kind of the unit of deploy for each service. So you'll say, okay, this is the way that I want one instance to be defined. And then so the next level up from that is an auto-scaling group. So an auto-scaling group is a way to configure, okay, for this role, for this auto-scaling group, I would like to bring up some minimum and some maximum number of instances of a particular launch config. So you say, okay, we have a launch config for our bookmark service, and so there's an auto-scaling group that goes to the bookmark service as well. We could just as easily have okay. So we have one of our services is Celery, which is a Python asynchronous worker service, and we have one launch configuration for that because it's a particular set of it's a particular way of bringing up an individual server. But we have two auto-scaling groups, and they scale on different properties. One scales on CPU load, and the other one scales on They scale based on the same thing, but one scales on brings up spot instances rather than on-demand instances.
But didn't we find we actually do need two different launch configs for that? Because you do actually have to put the spot price in the launch config.
Oh, right.
I think that's one thing. Actually, this is the sort of thing that as we start moving towards having some of those configs in Chef, and we're starting to drive a lot of this is all the stuff we do around our Docker environment with Chef, then we don't accidentally forget, because I know I've done this. Remember that, and I think maybe you have too, is like we go and we set the same kind of launch config for our spot and non-spot, so we just end up not using the spot instances. That's the sort of thing that it's easy to forget, and I think that I've definitely done it.
When you say driving it with Chef, are you using Chef to drive the launch config build?
The creation of the launch config. So like we can we're just in the process of starting to set that up now. But this is the kind of hilarity of having something that's totally modern day, and we use all sorts of Docker, and we're using config management for what? Oh, nothing? Really? And that's like, Docker files are fantastic, but they aren't going to necessarily like remind you that your template for a launch config should look like this or whatever.
Right.
On that note, and I'm going to put on my Chef hat for just a second and say, if you're using the Chef provisioning gem stuff to do that, you should totally reach out to John Kaiser if you run into things. And they've got a Gitter chat that they watch. So if you've got any like input or like, oh my God, it's broken, you should totally reach out.
I'm pretty sure that the coworker Pete and I are going to be talking about some of the stuff that we've been implementing and trying to put Chef around a lot of our needs here at Drama Fever. Mm-hmm. We're going to be talking about that at ChefConf actually, and so I imagine as we're trying to as we do the parallel tracks of doing all the things and also preparing our talk for all the things, we'll probably come up with stuff that we want to ask about in more detail.
Awesome.
Actually, okay. I'm sure our talk is going to have a certain number of, or a certain amount of, and these are the things that we still totally haven't figured out yet. Hey, audience, you're all chefs.
Well, and that's the fun part about all of this, right? Like, it's such a weird thing, and this is something I forget sometimes, that like what we're talking about is like and forgive the expression, the bleeding edge. Like, it's not even leading edge, it's bleeding edge. It's, oh my God, we are going to hurt ourselves at times because of the things that these systems are doing. And it's non-obvious to a lot of folks because it really, there's a lot involved. And so the interesting place that there becomes fun discussions is, well, okay, so your launch configs and all that stuff, well, you can go like down 3 different paths as to how you're getting that in. Obviously, you guys are looking at Chef. You can do it manually, which is the way I've always done it. Which even tells you how long after it being available I started playing with it, because originally launch groups or auto scaling was only available from the API. You get into discussions around cloud formation and Terraform.
I made a Terraform module to do this yesterday.
Nice. And I think there's at least one other product out there that does, and then you get into, my favorite is if you've ever sat in a conversation with RightScale, they'll sit and tell you about their custom stuff that does auto scaling but doesn't use auto scaling.
Is that sort of like the stuff Brandon was describing? Because the reason that we're here today, and I imagine probably a bunch of people saw us having this discussion on Twitter, but Brandon was saying, hey, who uses auto-scaling stuff? And I was like, hey, we use it. What kind of questions do you have? And he was like, I'm doing all of this fancy stuff with like Knife EC2, blah, blah, blah. And I'm like, really? Because he's like, does auto-scaling do that? I'm like, I think so. It might meet your needs. And then I think, Brandon, you just jumped in and started using it right away, right?
Yeah, well, it was like another week or two. I did a little research, but now I started to play with it because part of what we're figuring out is like, we're really looking at Terraform sort of as a way to manage. The goal is we want to more programmatically manage our AWS resource creation and define that more commonly, and but also figure out a way to do it that sort of sticks to the dry principle, things like that. So looking at tools, and Terraform seems to be a good option because we're already using Packer and Console with Vagrant, and part of that is right now kind of our deployment model is using Knife EC2 and some shell scripts, and like the shell scripts do like just some basic round robin amongst a list of subnet IDs to do instance placement. And that was one of the big ones of like, how can I replace that? And then like ASGs seem to be a way to do that.
Sure.
But one of the sort of things I'm looking at, as I've just been getting up to speed on ASGs for a couple days, is a lot of what we sort of don't want the scaling piece isn't as much what we need. We don't need the dynamic dynamicism or whatever isn't as much we're looking at. More is like ASGs seem like a really easy way to define a way to have, give me n number of instances of a certain type, and that type is based on a launch config, right, which is some AMI that we bake, and then user data to make it usable, and then also potentially manage the elastic load balance association simply based on here's an ELB name for, I give the ASG an ELB name, and then the rest of that happens sort of magically. But it's more around like a lot of steady state sort of thing, sort of workloads.
So we use that for some of our more steady state workloads, really in a very similar way, and it works really well for us. And it has a couple other advantages in addition to like the configuration side of it. It has the kind of like ongoing maintenance side. So like when you get those, every couple week emails from Amazon saying, oh, by the way, instance ID blah 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 is going to go bad on you, so you're going to have to move it to new hardware or kill it or whatever. In our environment, we remove it from the load balancer and terminator, and then even on those steady state instances, the auto scaling environment will say, oh, all right, you only have 2 where you had 3 of those, so let's bring up the third one, and we don't even so that kind of like ongoing operational stuff gets a little easier too, because then you don't worry, it forces you, partly because it forces you to not worry about the underlying instance. You just say, oh, okay, I know that I can always get that. I can always get another one of those instances very easily.
And another thing that made this really nice, actually, was the great AWS rebooting of October 2014. Like when we had I suppose anybody who's using AWS probably, suffered through that to one extent or another. And it was fairly painless compared to what it could have been in our environment, because a lot of it was, they're going to target all of these of our instances. Okay, well, that's fine. We'll just kill a whole bunch of them ourselves ahead of time and then roll the dice and see if it spins up a new one that's not going to be affected by,
Well, and the cool thing about auto scaling, and I hadn't thought about it until you guys pointed it out, or folks pointed it out. I'm going to learn how to not say guys, darn it.
Thank you, Chris.
Um,
Even though the second person doesn't actually bother me as much, but
So I think the thing that really is interesting to me is we talk a lot about this idea of stateless machines and really that idea of like you log into a box, you make changes to the system, and there's one side of the fence that's, oh, we should completely remove developers' SSH access and sysadmins' SSH access. Everything should be done through chef, which, like, pardon the expression, but cool story, bro. Like, that just doesn't work, right? Like, you have to be able to get on the box to just even figure out what's going on. But there's this kind of ideal world where you log into a box, and unless there's some other mechanism to prevent it, it would be really neat to be able to just destroy the instance when you log out or some period of time after you log out. And I wonder if that becomes one of the bigger benefits of doing so, right? Like, can you let it do its thing, and when you log out, it automatically sends a hook to some service, and if after half an hour it kills the instance.
I mean, we don't actually log into our instances all that much. I mean, there are instances, like more dev-focused stuff that we do log into, but I think that autoscaling helps us a lot in living the actual pets, cattle not pets thing, because even there's been instances, there's been times that I've been trying to track down some sort of bizarre problem that's happening, and I'll actually have to, artificially tell the autoscaling group not to kill off, just kind of set our desired and then to n+1, and then set it to suspend processing or whatever, just to give maybe Tim a chance to log in and look at the one that's misbehaving, and then he'll say, hey, we don't need to try to diagnose this, let's just kill the instance. But sometimes if something is going wrong and you're like, you can't reproduce it on demand, it's nice to hang on to the one that's horribly broken so you can at least try to see it in action. But I mean, usually if an instance has terrible problems, just getting rid of it and getting a new one is way better than trying to deal with any kind of weird one-off type, intermittent problem.
Well, and that's where it becomes fun, right? Like, if your problem is that it's one intermittent, you just have a node that's in a bad state, we'll destroy and rebuild it.
Right.
If the problem is that the service has a weird issue, and gosh darn it, you can't figure out what it is, a lot of what I deal with is Rails apps. There's something to be said for being able to jump in and run Rails C and be like, oh, that data didn't come from, huh? Yeah.
So
or oh, this instance is eating this service is eating all the file handles in the box. That was a real problem that we had once, and I wouldn't want to give that up, to be a completely like Google App Engine style, where it's like this kind of like abstract compute something that's abstract compute substrate instead of oh no, I really do want it to be an instance of some kind that but certainly that should be that it should be rare ideally, but
Yeah. And something else that comes to mind, like the just talking about how we interact with or don't interact with in terms of like SSHing to our environment, is Dave was asking on IRC about how we do our new container deploys, and that's our deploy process is a work in progress. I mean, isn't everyone's? I don't know anyone who's like 100% happy with their deploy process. I mean, ours is a work in progress, but one of the features I really like about it is that it emphatically does not have us, going to logging into, caring about, or even knowing how many we have of the instances that we're deploying stuff to. Tim, since you designed it, do you want to give us a little bit of an overview of why you went with that general method?
Well, yeah, I mean, so why I went with it is actually because at the time that's exactly what it was. It was really so we use Fabric as an orchestration tool to do the deployment. And again, I will preface I'm not 100% happy with how we're doing it right now, but when I first started, it was even worse. And so what we were doing at that time was, and everybody here will laugh, this is wretched. We used Fabric to orchestrate a pattern where the Git repository of that Python code was sitting on the box and would get Git pulled, and then the service should get restarted. So we don't do that anymore, obviously, because that's terrible. But the idea being that you say, okay, with Fabric we orchestrate removing the instance, an instance from the load balancer, telling it to restart the service, and then once that service as part of its restart process pulls whatever the latest tagged container is. So I should maybe.
Yeah, so deploying something to prod involves a Jenkins build that builds, it actually is the QA container, like the actual container that went through QA that was, completely used and vetted and approved of by all of our automated and manual testing. That same container gets tagged for staging and then for production, and like hasn't changed at all. So that's one of the benefits of everything in our Docker, our Docker pipeline, is that the container that ends up being tagged as this is what's available now and should be used for prod, when the prod instances come out of the load balancer, restart there, it's just we just upstart. That's our. We're not going to talk about init systems, but and then just the restart part of the upstart jobs, pre-start script is to go and do a Docker pull. So that's how we get the most current container and make it available to the service to run that container on the host.
Do you have a common base image that you use across most of your apps? And if so, are you baking that into your AMI so that you have less you need to download from the registry on boot up?
So we actually experimented with that a bit. So the problem turned out to be with that is that that base image had to be updated at a rate which was faster than we were deploying things because of that. So let's say we're using an Ubuntu image as the base image, right? So when Heartbleed came out, like, well, okay, so all those have a vulnerable instance of OpenSSL, so the container base had to be rebuilt anyway, and would have had to been redistributed to all the AMIs. So right now we just build the entire bit. What we do on and so we don't ship that, and so no, we don't ship that on the AMI as a result of that because it would almost always end up being pulled fresh. What we do end up doing is we use for some of our larger applications, so like say our Django application, we take a new base image once a week, and that has both the operating system dependencies plus all the dependencies of the application, so all, Django itself and all the other things, and then we are the builds that happen on Jenkins, which happen every time a merge happens into the master trunk, those just build on top of that. So it reduces the total build time for those containers by quite a bit. Our Go services, that's less of an issue because the container is just so much smaller. Our current, we're using a from scratch container for, as we mentioned earlier, for our the one service bookmarks. So that entire container is 10 megs. So it's we just don't care, right? So it's so small that anything you would do to try to improve that is just going to make things more complicated and failure prone than having it.
Is the from scratch even smaller than BusyBox? Because I had done similar with BusyBox, where you just throw the Go binary on top of BusyBox. I hadn't thought of using Scratch.
The Scratch is
literally 0.
Yeah, you can create it by piping dev null to a container. So it only works. So I did not come up with this. I think it was Kyle Kingsbury did a really great blog post recently, maybe 4 or 5 months ago, about how to make a Go binary actually statically linked, because apparently there are a few things that will still rely on the underlying operating system. So you have to make sure that you're turning off cgo and things like that. But once you've done that, you have a statically linked binary that has no dependencies whatsoever. So that is literally the only thing sitting in that container. It makes it a little funny to work with because you can't shell into the container or anything, you can't do anything with it. All you can do is run your application.
It is sort of weird for testing. It's weird for testing.
Yeah.
I think when you first put in that PR, I pulled it down and I was like, I can't even do anything with this container. I have no idea if it's actually okay. Let's just try running the application exactly. Yeah, okay. I mean, it works.
Yeah. To do that, you have to make sure that you have really, obviously you have to have a way of validating that the container is, correct. So that's we try to, particularly with our Go applications, which are all newer code, and instead of our ancient creaking legacy code, which we all have. For those applications, we try to do a really good job of making sure that we have vetting tools so that this microservice, I can pass it a bunch of requests that are really just really detailed integration tests, I guess is to make a long story short there.
Oh, we should probably, since you're bringing that general topic up, we should probably talk about health checks a little bit. So with the auto scaling stuff, I mean, you can set your elastic load balancers in Amazon for people who haven't used any of this stuff. You have to, in fact, set some sort of health check. And of course, you could set the most naive possible, I don't know, ICMP or whatever. But we do have some of our health checks are just, is the application answering, and not, is the application functioning? So that can lead to wackiness, because if the health check believes that the application is answering and everything is super, then it won't bounce those instances out of the load balancer. And so our number of unhealthy instances, CloudWatch alarms that we have set to go to PagerDuty won't alert us because they think everything is copacetic, but the application will be dropping requests on the floor or whatever. So, I mean, there's places like that where you can paint yourself into a corner, and we have painted ourselves into a corner in a couple of areas, and have now started improving those health checks to actually, check for actual functionality as opposed to just, is this microservice answering?
Which I think leads to kind of an interesting thing that the combination of autoscaling and Docker and kind of the immutable host with the container dropped on it gives us is, what it's really let us do is, and this hasn't really been formalized in our organization yet, but is kind of like the idea that we're moving towards is that the operations team can provide effectively an API of sorts, meaning that so long as your application logs in this way and it gets health checks in this way and can be built with a Docker file, and answers on TCP port blah, like that it will work when it's deployed, right? So it makes the kind of the underlying infrastructure, it abstracts it away a little bit for the application developers, which can be really powerful.
And there's
that's a little magic-y, but it almost always works. It's getting better.
Well, we're trying to get better all the time, and I think we've even talked a little about, and Dave was asking on IRC, and I know Tim, you and I have talked a little bit about what we might want to try to move towards doing with like blue-green deploys and whatnot. Mm-hmm. I know that because and I was able to do blue-green deploys a lot more easily in an environment where we were using the hated MongoDB. Chris, are we allowed to hate on MongoDB? Or Brandon, are we allowed to hate on MongoDB? Because boy, howdy do I.
As long as we all understand that there are people behind MongoDB, absolutely. And yeah, I'm cool with that.
Yep, and I have trouble. I will. So anyway, it was. There was one really good thing about it, which is we spent no time whatsoever thinking about schema changes. So since we're using RDS and we're using MySQL basically, like we do have to care about schema changes, which means that we, in our deploy process, like we do make everything backwards compatible, but having a certain amount of, I don't know, like how would you put it, Tim? Just kind of a certain amount of fragility there that is possible. It's a little bit better now that we're on 5.6 and can do online migrations, but it does make our deployments a little bit less, I don't know, a little more difficult than they are if you have something in the back end for your data store where you don't spend any time worrying about about your schemas. So,
do you use any unmanaged like data tiers, or is it all like sort of that abstracted AWS services?
I'm counting. Sorry. Just the logging. So we have Elasticsearch for logging that we're doing. We have an ELK stack right now. But in terms of like primary data stores, they're currently all on. I'm hoping I'm not making a liar of myself, but I think they're all on the managed services these days.
Yeah, RDS, DynamoDB, Redshift.
Yeah.
So in other words, we're able to do the immutable servers because you're letting other people handle the mutable crap.
Oh yeah, totally. Yeah, I mean, yeah, I mean, I think you can't have any illusions about that. I mean, that's, but it could be done. I mean, like, so and I know that there are people who've done this where they run, say, they run their MySQL clusters on EC2 instances with EBS, and then use attachment and detachment of the EBS volumes or replication to handle some of the scaling issues around that. It also sounds like it's a huge pain in the butt. I think like the trick with that for us is that we were a startup, so certainly when I came on, we were definitely in the a couple of folks. I think there were a total of 5 people on the technical team when I started, and I was the first operations person. So it was those managed services things. They really save your bacon when you just don't have the resources to do anything else. So we've been moderately happy with it. RDS kind of bit us for a little while, but we've gone through some application changes and some just the product has gotten better. So that's good, and DynamoDB we use pretty heavily on some of our the bookmarking service, and we're really happy with that most of the time. So
Well,
Do
and
you
it's
scale Elasticsearch, or is it static?
No, that's static right now.
Yeah.
I think there's some stuff we're going to need to be doing in that direction, but that's not something that is, at least right now for us, in scope of like Amazon's auto scaling, because I mean, yeah, you can tell it any new nodes you add to this Elasticsearch cluster. Like, that is a thing, but we haven't focused on tying that into the auto scaling.
Actually, I kind of joined in to ask, or to at least mention similar things.
Peter.
I went into, hey, how's it going, Bridget? I did a lot of stuff at my last job with Cassandra in moving that to auto scaling groups. I just want to mention that you can do all of that because the API gives you a lot of stuff, if you're willing to put the development cycles in. But the one key thing to know when you're dealing with state and auto scale groups is there is actually a special command to kill a particular node and not have it come back rather than randomly or having it restore, so you can sort of control the state of moving things down and up.
Yeah,
So,
I mean, you can terminate instance in auto scaling group -- decrement capacity, or whatever they changed the syntax to now.
yeah.
That's actually a really interesting point that you bring up, Peter, which is for the stuff Brandon was describing, where you don't really plan on using it for constantly scaling up and down, but you might want to use it because it makes it easier to swap stuff out. You got to watch out for some of those the termination rules for auto scaling groups. I know Tim and I ran into that when we were trying to replace some instances, and this is not exactly the blue-green stuff Dave was talking about. It's more just the, we've rolled out a new AMI because of fill in your exploit of the week here, and now we think that the auto scaling is going to, we've set our desired instances back down to X, and we think that the auto scaling is going to kill the old ones. Well, maybe not. Like, the termination rules could be set for oldest instance, but what that really means is if you have the same number of instances in all of your availability zones, is first pick an arbitrary availability zone and then kill the oldest instance in that zone. So if you are just doing this for redundancy and you have maybe 2 instances in each zone or whatever, it's like, and you've only swapped out the instances in some or versus another, you can end up killing your new instances, not your old ones, without expecting that. So it's like, but you don't want to be all treating them as pets and going and finding out the exact instance ID of the one you're trying to terminate. So that kind of, there's other termination rules you can set. I think what we ended up going with in some of those cases was oldest AMI, wasn't it?
Yeah, I think it's oldest launch config.
Or oldest launch config, that's right.
Yeah, that makes a lot of sense. But yeah, it's a tricky problem, is sometimes knowing how to control things going down. The autoscale groups are much better at sending things up because they do what you ask for more predictably.
Sure.
Well, and that also, there's actually, I thought that I just saw something about Amazon added, like for spot instances, that you can now get a warning before a spot instance is killed. And I think that we're going to probably be able to use that because right now, the auto-scaling Calm stuff, when it takes, say, one of our request path instances that's like a dub instance out, it takes it out of the load balancer and lets it finish its connection draining or whatever. It's that connection draining setting, I think, that controls that, right, Tim?
Mm-hmm.
And so we're not going to be taking an instance and terminating it so abruptly that it would affect, users like in flight. Whereas if we were using spot instances, up until this recent announcement of Amazon's, if we were using spot instances for our www nodes, an instance could just get unceremoniously terminated and not pulled out of the load balancer and not let any connections drain. And so I think what we'll be able to do now, and I think I opened myself a ticket for this, didn't I? That I'm going to investigate just throwing a script in that checks to see if the instance is about to be terminated, because Amazon now gives you like a, 1 minute or 2 minute warning or something. And then we can pull it out of the load balancer at that time and then let it finish its connection drain before it gets terminated. But there's definitely stuff like that you have to stay on top of what Amazon is offering you, because of course it changes all the time and usually in a good way. Like they're always adding great new things, but
I've got to run off, but something that is interesting to think about is how does Lambda play into this? Because in concept, you could take that notification, drop it on. I forget if you would end up in an SNS to an SQS to Lambda picking up that worker, or those or tossing it in DynamoDB, but effectively bouncing that through and just having Lambda hit it instead of having to run a worker. On that note, I'm out.
Hi. Bye, Chris.
Thanks, Chris.
That's actually a really interesting question. I mean, obviously, I think right now Lambda is still pretty node-based, right? Like I haven't actually played with it. I just saw some demos or whatever when it first started up. But
yeah, it's
right
all JavaScript.
Yeah, so I mean, it doesn't necessarily meet a lot of our needs. Well, though I have seen demos where people took that and bootstrapped other stuff. So I'm not sure that would definitely be out of the question, but I'm not sure it also meets our actual needs at this moment. You did mention earlier, though, Tim, right, that you kind of prefer to have a little bit more control over, as opposed to just sending stuff to a node that has been abstracted that much. Like, what do you think?
Yeah. I mean, I think it's kind of the same reason why, and I although they're all great guys, folks over there, a company like Heroku is not really, in addition to cost, is not really what we want, because we don't want to have, completely abstracted machine. We want an actual machine that we are, because for reasons like we could never have built the infrastructure we have with Docker if we were using something like Google App Engine, or that it's just we would have had to wait for them to support it instead of being able to do it on our own terms, at our own, at the risk profiles that we're comfortable with and things like that. So, having them be on EC2, real EC2 instances, it has a lot of value for us, I think. Which is probably sounds a little bit at odds with the question of the managed services versus unmanaged services, but I think there's we draw kind of some arbitrary line where we say, well, these kinds of managed services are the ones that we want to have. Things where our code is running are the ones where we typically want to have more control than on a managed service.
But isn't that going to be the case for most places? I mean, most places that everybody has to make the that trade-off, right?
Sure. Yeah. I just don't want to.
Everybody's going to draw that line in a
slightly different place. Nobody else can use Lambda. That's
No, but everyone's going to draw that line in a slightly different place, and it's going to be in a different place for everyone depending on their actual use cases, right?
Sure. Yep.
Let's see. I think.
Yeah, I think that's a good place to end it. So
yeah.
We're out of time.
Awesome. Well, thank you.
Well, thank you so much, Bridget and Tim. This has been really informative, really good.
And thank you so much. This has been super fun.
If folks want to, find out more about you or follow along with what you're doing, where can they find you both?
So they can find us on Twitter, and I believe there is also going to be a tech blog for Drama Fever coming out in the very near future that is going to have lots of our thoughts of our team and the rest of our development team. So that should be fun too.
Yeah, that's the tech blog. Tech blog is a work in progress that I'll definitely be tweeting about when we actually get that off the ground. And I think finding us, until then, finding us on Twitter is probably the easiest way. So.
All right, cool. We'll call it a day there. Thanks, and have a good weekend.
Thanks.
All right. You too.
All right.